Okay. So first you have to press this button, Y1, Y equal to, okay? You can key in Y1, Y2 up to you. So we stick to Y1. So if you have anything in Y1, what you need to do is you put your cursor to there, then you just press the button clear. So everything will clear off. Then you can start to type in. So can you? Type in already? Anyone got issue of typing in? This one you have to press the power button. Then this is a minus button. You know how to call out E, right? Okay, done. So second step, you go to window. Okay, you set your X minimum as negative. Please. Negative, you must use this button. -4. And your X maximum as 1. Done? So third step, you go to zoom. Okay, then select 0, there is zoom fit. Okay, so the graph will come out. All the others you please delete off so that it won't disturb you. Okay, so when I do a zoom fit, okay, I believe everyone, you got your screen go like that. Am I right? You got the axis here. And it look like here, look like a straight line like that. And you go up like this. Am I right? So you can't really see the turning point. So I'm going to teach you how to see the turning point. Shall we? Okay. So I'm going to teach you how to make some adjustment so that you can see this part clearly. You get me? Okay, so everyone, have you got until the whatever I've written down here? Yes or no? Can someone respond? Okay, yes. So now, okay, look, so I'm going to see this part clearly. I'm going to do some changes, okay? I'm going to do some changes. Okay, are you okay? So now, can everyone from here, okay, so you go back to window. Okay, you go back to your window. Okay, everything you don't do changes. You go and look at your Y minimum. Don't do anything. Y maximum. Okay, we are going to change our Y maximum. Our Y maximum is 12.05, correct? So now, I'm going to change this maybe to just 1, 2. Okay, you change to 2. You want to change to 3 also can. So everyone do that. I change it to 2. Okay. Then after this, I go and press this button graph. Okay. So now can you see the turning point quite clearly? So if you want to see the turning point clearer, what you can do is you can turn this to 1.5. Okay. So now whatever come up on your screen, now it look quite obvious, correct? You can see the graph go like that and turn, then go up. Am I right? Hello? Okay. So for part B, there is a way for us to find. Okay, look, find the coordinates of fx where its rate of change is 0. Okay, what do you mean by rate of change is 0? That means I'm talking about my f prime x equal to 0. Are you okay? So that is the meaning of rate of change equal to 0. F prime x equal to 0. So it happened at the stationary point. Okay. And this one, this point, we call it local minimum. Okay. So we can use our GC to find this point. What you need to do is you go to your graphic calculator, you do second trace. Like yesterday, we look for the 0, correct? So you go second trace. Do you see second trace? You go down. Do you see number 3? You select number 3. Then there will a dialog box come up. Okay. Do you have a dialog box come out? Yeah. Left bound, right bound. Same story like yesterday. You use this cursor to move. This one and this one. Move to the left. The moment your cursor is at the left here of the turning point, you press enter. Make sure it will go right to the left. Okay, then you press enter. Got it? Then the dialog box come out right bound. So now you use this one to move the cursor to the right of the turning point. Yeah. Then you enter. Got it? Then the dialog box there will say guess. So you press enter again. So do you get the answer? Everyone should get this point as negative 1.386 and comma negative 0.125. Do you have that? Hello? So everyone okay? So you see, that is how your graphic calculator works. Okay, because this question says find the coordinates of fx where its rate of change is 0. They didn't ask for exact value. You can use your graphic calculator to find. If they ask for exact value, then how are you going to do it? Hello? Okay, I'm going to teach you how to find the exact coordinates of the stationary point. Shall we? Okay, huh? Okay, so I will do part B by using calculus, huh? Okay, my function is fx equal to 2e to the power of 2x. Take away e to the power x. So now, first, you must get the gradient function. So do you know how to get the gradient function? That means you have to get your f prime x. So everyone now try to differentiate. Try to differentiate this. Okay, I presume everyone got the answer already. So f prime x exponential, we copy down the whole thing times by the derivative of the power. Take away, copy down the whole thing times by the derivative of the power. Am I right? Okay. So now we have the gradient function. So second step is stationary, rate of change 0. Sorry, not stationary. They didn't say stationary, okay? Rate of change 0. Imply f prime x equal to 0. So I have 4e to the power of 2x minus e to the power of x equal to 0. Yep. So now, do you know how to solve this? Okay, we go back to our indices. E to the power of 2x can be written as e to the power of x squared. Am I right? Then we let e to the power of x be equal to k. So now you try to solve this by yourself. Okay, so I will have 4 e to the power of x squared minus e to the power of x equal to 0. So 4k squared minus k equal to 0. So I factorize out the k. Yep. So k is e to the power of x, correct? So e to the power of x equal to 0, or 4e to the power of x minus 1 equal to 0. So e to the power of x is equal to 0, there is no solution. Correct? We say e to the power of x is always greater than 0. Am I going too fast? Okay, so my e to the power of x will be equal to 1 over 4. All right? So for exponential, if you want to find the x, what we need to do, we change it to ln. X equal to ln 1 over 4. Yeah. So yesterday we learned the formula. Ln is ln 1 minus ln 4, correct? And what is the value of ln 1? 0. So this is equal to negative ln 4. So if you use your calculator, so this is the exact value. So if you use your calculator to count, it will be negative ln 4. Okay, you use your calculator and count. Negative ln 4. So you get negative 1.386 as what we get just now. Okay? Hello? Are you okay? Okay, so I got the x. So now I need to know what is the y coordinate, correct? So my x is negative ln 4. Okay, I want to know what is the value. So what you can do is, student, this is 2e to the power of x squared minus e to the power of x, correct? So you have a look at here. You don't have to substitute x. You just need to substitute e to the power of x here. What is your value of e to the power of x for this case? It is 1/4. Am I right? So I can make my life much easier by substituting my e to the power of x as 1/4. So my calculation will be much faster. So this will be 2/16, take away 1/4. So there 1/8 minus 1/4. So this is negative 1/8. Are you okay? Got it? So this will be the question. If it really come out in your, it can come out in your SAT one. They ask you for exact value. So the coordinate will be, the exact value will be, oh, you are in the library. Okay, negative ln 4. Okay, so you just listen, okay? Negative 1/8. Yeah. So that is the exact turning point. Can or not? Okay, so let's go back to just now, the other part. Okay, find the value of its x-intercept and y-intercept. This one you know how to do, correct? Yeah, x-intercept and y-intercept. Okay, so please do that. Your function is fx is equal to 2e to the power 2x minus e to the power x. Okay, so we want to talk about y-intercept. So f0 when x equal to 0. So 2e to the power 0, take away e to the power 0. Okay, what is e to the power 0? Everyone, you better remember it because your SAT one, you cannot bring in your graphic calculator. So anything to the power of 0 is 1. Okay, so it's 2 times 1 minus 1. So the answer is 1. Okay, to find x-intercept, you go through just now the story again. So that means your y equal to 0 to e to the power x squared minus e to the power x. Yeah. So let e to the power x be equal to k. Then solve for k. So I give you 1 minute to get your answer. So go back to the same story. 0 equal to 2k squared minus k. So you can factorize out the k, correct? So I have 2k minus 1. So k equal to 0 or 2k. So my k is e to the power x. So this one is no solution. Or you can say impossible. Okay, so my k here is equal to half. Okay, look, if you want to prevent yourself from that one, what you can do is you can write this as two to the power negative 1, correct? Then this power you can bring in front. So it becomes negative ln 2. That will be a much better one. Are you okay? Hello? Okay, huh? So we proceed. Can you please proceed to part D? Yeah? Okay, Anna? Okay, so when you sketch the graph, first step, you key in the function, then you go to window, you set your domain, you do zoom fit, so the graph come out, you get the maximum point using second trace max, then left bound, right bound, get the minimum point using second trace, minimum, left bound, right bound, guess. Okay, then the value of when x equal to negative 2 also can get from second trace value x equal to negative 2, put enter, then the y value will come out. Okay, then from here you will have the range is y is a member of real number, and y for this domain, y is between negative 24 to 1.89. Are you okay? So when they ask you to sketch a graph, you have to tell me the coordinates of the stationary point, okay? Okay, then using calculus, find the coordinate of fx. Okay, now may I know, how are you going to find the dy dx of this? Can someone tell me? So now you start to find the dy dx for the fx. You expand, okay? Because this can be expand easily. So please expand and find the f prime x. Power take away 1. Multiply by the power take away 1. Okay, so 6, the rate of change of 6x is 6. Okay, so now everything got 3, so we factorize out the 3. So we got 3x squared minus 2x minus 2. Yep. So in this case, they want the f prime x equal to 0. So you equate equal to 0. So 3 cannot be 0. So therefore 3x squared minus 2x minus 2 equal to 0. So those of y'all, you have a graphic calculator, correct? A scientific calculator whereby you can you can find the actual coordinates, exact value, correct? Then you don't have to use the formula. Okay, but those who don't have, cannot give you the exact value, then you have to use this formula, x equal to negative b. Still remember quadratic? B squared minus 4ac over 2a. So this is an important formula. Unless your scientific calculator can give you the exact, then you don't have to remember this formula. Are you clear? So this is your b plus or minus square root of b squared minus 4ac over 2a. Okay, so you have 2 plus or minus, yeah, so this is 4 plus 24. So this is 28 over 6. So this is 2 plus or minus 28 is 4 times 7. So this is 2 root 7 over 6. So it will be 2, factorize out the 2, 1 plus or minus root 7 over 6. So it will be 1 plus or minus root 7 over 3. So this will be your x. After you get your x, you have to put into your fx to get your y. So there are 2 stationary points. You get me? So this is the exact value. So the exact value for x is, there are 2 of them. One is 1 plus root 7 over 3. The other one is 1 minus root 7 over 3. So this is what we get from our graph just now. Root 7 is about 2 point something. How Miss Do know root 7 is 2 point something? Can anyone tell me? 2 square is 4, correct? 3 square is 9, correct? 7 is between 4 and 9. So that's why root 7 is 2 point something. Yep. Okay. So I give you enough practice